A block of mass 15 kg is placed on a long trolley. The coefficient of static friction between the block and the trolley is 0.18. The trolley accelerates from rest with 0.5 meter per second for 20 seconds and then moves with uniform velocity. Discuss the motion of the block as viewed by a stationary observer on the ground. Using the Newton's second law of motion, we can write force is equals to mass into acceleration. Putting the mass and acceleration, we get the force as 7.5 newtons and its direction is in the direction of motion of trolley. The frictional force is small f, that is equals to mu into m into g. As we know, the frictional coefficient of friction is 0.18 and mass is 15 kgs and acceleration due to gravity is 10. Therefore, the frictional force is 27 newtons. Since the frictional force is greater than the applied force, so the block will appear to be at rest when seen by any stationary person. In the second case, we have to discuss the motion of the block as viewed by an observer moving with the trolley. With reference to the observer moving with the trolley will be at rest as a pseudo force will act to balance out the frictional force. In relative motion, both are moving together, thus are rest with each other.